Good morning, good evening, good afternoon, wherever you're joining from, welcome to this talk. My name's Robin Moffatt and I'm coming to you today from the lovely northern English town of Ilkley. And you can see in the photo here there's lots of lovely moorlands nearby. It's a very nice place. And from here we've got lots of towns and cities nearby that we can go to, and when we go to them we sometimes drive there. And drive there we need somewhere to leave the car, and so we've got car parks nearby. In the west of Yorkshire we say car park, elsewhere in the world they probably say car park. Anyway, car parks, you need somewhere to park your car, and sometimes there's space available and sometimes there isn't. Which leads to questions like, well, which spaces are there available? And which car park has got spaces? And is there one that's nearby where I actually am? And actually, can you tell me when there is a car park that has got some spaces? Because sometimes they get busy. And even, it'd be quite interesting to know how it fluctuates over time, so maybe we can plan our journey around when there are empty spaces, which is maybe overanalyzing it, but what's this kind of thing if we can't have fun? So as I say, my name's Robin Moffatt. I work at a company called Confluent. Confluent are one of the companies behind the open source Apache Kafka project. We've got our own distribution of Kafka called Confluent Platform, and also a managed Kafka and Confluent platform in the cloud called Confluent Cloud. I've been doing this kind of thing in data and analytics for a few years now. I like blogging an awful lot. I do conference talks and meetups. I've even got my own YouTube channel, courtesy of Lockdown. So what I want to show you today is how we can build something using a simple REST API like the one that the car park happens to expose, telling us how many empty spaces are out there at the moment, and how we can build something around that using a few different tools in the toolbox. We can use something called Telegram as our platform for the interface out to the user. Telegram, if you're not familiar with it, it's kind of like WhatsApp or Facebook Messenger. It's a generic messaging platform that's got all the extra bells and whistles that they always add on, but at its heart, it's a messaging platform. It's got an API, so we can write a bot that goes against it and sends the messages and can interact with us. So that's the end of the slides, because it's much more interesting to actually see this kind of thing in action than it is just to see a bunch of slideware. I'll share the slides afterwards, and the slides have got all the kind of like diagrams and the kind of stuff that you'd expect, but let's actually go hands-on now and see what it looks like. So to start with, let's have a look at the bot itself. So Telegram API, it's very nice to work with. And I've got this simple example here that I'm going to show you. I'm using Go, partly because it's been a project of mine to learn it recently, and partly because that's the example I have to hand. And so in this example here, this is just for the Telegram bot itself. We're not doing anything car parky yet, we're just looking at the Telegram bot. So here we're using the bringing in the library itself. This is a third-party one that I've brought in, very nice and easy to work with. We need to pass in a token, which you go and create a bot in Telegram and you get an API code. And from that, we connect to Telegram, we subscribe to updates, so when someone sends us a message, tell us about it. And from there, we just set up a loop which says, well, we're going to sit and wait using this for loop here on the range of the updates as they come in. So that's going to keep on until it gets closed. And then as each one comes in, we look at what kind of thing it was that's been sent to us. Have they sent us a command? Have they sent us their location? Or we're going to assume if it's neither of those things, it's just some text. And then in each of these, we've just got a bit of dummy code which just says, oh, well, it was an update, it was a location, and whatever. So let's run that and see what it actually looks like. So we say go run, and that's going to spin up the bot. It's going to say, okay, now we're running and we're listening, and I can click on this here, and this is going to go and launch the Telegram bot. And we can bring that onto the screen here. We can do this, so you just see the actual thing itself, and it looks like that. So here's the Telegram bot. You can see I've been playing around with this already, but if I move this so you can see both the bot itself and the code in the background, if I say hello, we can see over here it says hello right back at you. We can see in the bot itself it logged the fact that it received it, and we can see that, and we can see it logs it down here. We can send my location to it. So we're building up the pieces here that are going to be useful for building a bot that's going to interact with us at the car parks. So if we just click on somewhere on the map and send that as a location, you can see we received the location over here, and you get the longitude and the latitude. So you can do a bunch of cool stuff, and all I'm doing here is sending stuff through this, and it gets sent over there, and we send something back based on that. So that's the Telegram bot, the kind of like the shell of it, and then we're going to build in a bunch more stuff. So to start with, let's think how we're going to get the data in from this REST endpoint that we've got that holds information about the car parks and how many spaces they've got available. So that's actually available. It's a REST call that you can make, and you basically just get a lump of CSV code back. So let me show you what that looks like. So if we run this bit here, and we're going to clear the screen there and paste that in. I'm just going to use curl to go and fetch it. So it's from this particular thing here. So it's the Northern Data Hub in the UK who make this available. And you just get a lump of CSV back. You get the header, and then you've got the different fields. So there's several different car parks, and you've got stuff like the capacity, you've got the available spaces, and the location of the car park. So what I'm going to do is I'm going to stream that information into Kafka, because Kafka is going to be our persistent data store here. We're going to use it for being able to sort through these events, being able to materialize state over these events, and do a bunch of useful things with it. So to do that, to get that into Kafka, I'm actually just going to use a little trick here to take the data that comes out of curl, that's called out to that REST API, and we're going to pipe it into a Kafka topic. And that looks like this. So we're going to stick a while loop around it, because we're going to keep on polling that endpoint. We're going to do this every 3 minutes. So this is fairly rudimentary approach here. It's kind of not particularly bulletproof, but it certainly works for the purposes of this. And we're going to take that curl, we're going to pipe it through tail to strip out the header. And then we're going to pipe it into Kafka Cat, which acts as a producer in this case, taking the standard in that comes through the pipes and pipe it into a Kafka topic called car parks. So we do that, and that's going to sit there. Okay, so it's got a while loop on it, so it's just going to keep on doing that every 3 minutes. And if I split the screen here, and if I run Kafka Cat like this, and we run it with -c instead, now we can consume from that topic, and we can see we've got data sat in that topic. And if I go back up to here at the top, and if I run that command again, and take that -t off so it doesn't echo it to the screen, put some more data into the topic, and we can see at the bottom of the screen there, we've got more data arriving in the topic. So I'm going to leave that running. So at the top of the screen here, we've got our while loop, which is polling the REST API, pushing the data into Kafka. At the bottom here, we're simply consuming from that topic and echoing out to the screen anytime we get new messages. We've got a bunch of CSV data, and we want to do something with that. We want to say, we'll take out the field that holds information about the spaces and the name of the car park, and we want to pull out those things. Because we want to do things like tell the user when there's a car park that has spaces available. Or we want to be able to ask the question when the user says to us, how many spaces does such and such car park have available? We want to actually materialize that state off that stream of events and say, well, currently this car park has got this many spaces available. We even want to be able to do something cool, which is to say, the user says they are here. Let's look at all the different car parks, work out which one is closest, and then tell them which one's closest that has available spaces. So to do that, we need a bit more than just some CSV data. So to do that, we're now going to use ksqlDB. So ksqlDB, it's this event streaming database. It's built on top of Apache Kafka. And if you can distill it down several layers of abstraction, it's just a producer and consumer on data in Kafka. But it actually gives us this nice high-level abstraction on top of streams of data, both to work with them as streams of data, but also very cool to work with them as state. So to take a stream of data or to take a table of a stream of data. So this gets a little bit funky, but we're going to see how it pans out as we go through. So the first thing we're going to do is we're going to create a stream in ksqlDB. And this is kind of declaring a stream on top of an existing topic. We're going to see later on how we can create new topics that are populated through ksqlDB. For now, we're simply saying we've got an existing topic called car parks, and the data is delimited, it's comma delimited, and here is the schema of that data. So the schema we've taken from the headers that came through in that CSV file, and then the data types we've had to figure out, and it's like, well, the capacity is an integer, and the latitude, longitude are double, so we've had to do that bit ourselves. So we create the stream, and with a stream created, we can actually now project some particular fields from that payload. So we can do this. Go back to the beginning of the topic, this auto offset reset, and now just give me some of those particular fields from this stream. We're saying emit changes, show me the data as it changes, just show me the first 5. So saying, okay, here you go. At this particular timestamp, this particular car park had this many empty spaces. I could leave it running, so let me take off the limit, and it says emit changes, and that's just going to sit there, and it's going to keep on ticking over until we get new data arriving in the topic, and then it'll update it on the screen. So that's our stream of data, and with that stream of data, we can now process it further. We're going to do a few things before we actually start building it into the Telegram bot. We're going to take this date and time and we're going to build it into a proper timestamp because we're going to do some kind of time calculations on it. We're also going to take that latitude and longitude that we've got and we're going to build it into a struct object. And we're also going to reserialize the data into protobuf because the schema is really important, and having to declare out that specific schema every time we want to use it, it's inconvenient for us. It's also really inefficient and error prone for all the other people who probably want to use that data as well. So we're going to declare a schema up front, we're going to store that schema in the schema registry, we're going to serialize the data using protobuf, and now anyone wanting to use the data, us, anyone else who has access to it, can just pull down the data and have the schema already. So let's see how we do that. So again, we're going to say set the offset to the earliest to make sure that we're processing all of the data in the topic. And now we're going to do another create stream command, but this one is going to say I would like to create a new Kafka topic and I would like to populate it with the results of a select statement. So it looks fairly similar, create stream car park, but now we're saying we're going to change the serialization that's being used. So we're going to serialize it into protobuf, and we're saying as the results of this select statement. So I could run that select statement on its own and it would just echo it out to the screen, but this time we're saying we'll take that and instead of echoing it to the screen, write it to a new Kafka topic. And it's a continuous query, it's going to keep on running. So as every new message arrives on that source topic, it's going to get processed by this select statement, which runs continually. We're going to take the timestamp, we're going to create it into a proper timestamp format. We're going to take the latitude, longitude and build it into a struct. We're going to serialize all of that into protobuf and write it into a new Kafka topic. So we set that running and it'll say, okay, I've created a new stream, I've set the query running. And we can say, show streams. This is okay, you've got a new stream. Here's one called car park events and it's in protobuf. And we've got a new Kafka topic of the same name. So at this point, anyone can connect to our Kafka cluster and they'll see a Kafka topic called car park events, and they could read from that topic, deserialize the protobuf and use that data. So you can actually use ksqlDB simply as like a stream processor that takes some data, does some stuff to it, writes it back to a Kafka topic, and now other applications can use that data. So we're going to do a little bit more than that. What we're going to do is we're going to say, well, let's take that data. Let me just show you what it looks like, just to show that it's definitely working. We're going to say select the timestamp, and now we're going to take the timestamp that we created and actually format it back to our own timestamp format that we can see that's human readable, because it stores timestamps as big ints, epochs, and then the name of the car park and empty places from here where the car park matches a certain name. This is okay, we've got 3 different readings for the Westgate car park. We got 2 at this particular point, which is at the beginning there when I was kept on running that curl command, and then we've had another reading here. Here's the number of empty places, so we can see 2 more people arrived at the car park, so the number of empty places has gone down, but we've got that data as part of a stream. So what we're going to do now is we're going to create a materialized view on top of that stream of events. This stream here already gives us the ability to answer the question, tell me when a certain car park has got more than a certain number of spaces available, because we can run a select statement. In fact, let's do this. So run from here, and instead of where name is Westgate, we're going to say where empty places is greater than, let's say, 100, and emit changes. Oops, get your keyboard right. There we go. So now we've got a query that's just going to tell us every time we get a new message that arrives that matches the predicate that we specified. So the predicate up here where empty places is more than 100, we're going to get a message pushed to the screen. And what we can do is we can run that from a client and say, well, the client's going to receive a message every time a message meets that criteria. So we'd probably run it with the offset set to latest. So let me show you that. So we've got latest here. And now when I run that, it's just going to sit there. It's going to say, well, I'll go to the end of the topic. And now any message that arrives subsequently meeting that criteria will get echoed out to the screen. So that's how we can satisfy that first requirement of tell me when a car park becomes available with a certain number of spaces over the threshold. So this is called a push query. So that's the first one. The second one we're going to do is we're going to say, I would like to know how many spaces are available at a specific car park now. I would like to do a key value lookup. I would like to take this stream of events and I would like to do a lookup against that. And with ksqlDB, and this is where the DB bit of the name comes in, you can actually materialize that state within it itself. We don't have to take a stream of events and shove it down to another data store somewhere else. We can take a stream of events and materialize it within ksqlDB and then do lookups against that state directly. So let's see that. And to do this, we're going to create ourselves a new object. But instead of creating a stream this time, we're going to create a table. So a table is key value state. And the state is going to be things like the number of empty places or the percentage full. And the key is going to be the name of the car park. So the name of the car park is our key. The value is all the other pieces, so like its location and its percentage full. And you can see we're using ksqlDB and we're running a bunch of SQL. We're doing functions and calculations, and we're changing schema because we can use the as operator to change the name of a field. So we set that running and we go and create a table. So now we can do this kind of key value lookup. We can say, I would like to know how many spaces are available at a particular car park. And you'll notice here I don't say emit changes. Here I'm just saying I would like a key value lookup. I would like to pretend that this is a database, which it kind of is if you squint. I would like to say, what's the current state? And it says, well, here is the current state, and then query terminated. So the latest timestamp was this. This is how many spaces there are currently. Has that changed? I don't know. I'll have to rerun that query. As opposed to a push query, where we say, here is the current value, or here is the current value when we get one in, and any time it changes, the emit changes bit, we will tell you it has changed. So pull queries, key value lookup point in time, and push queries, as and when it changes, tell me about it. And we can say, you can do that from the beginning of the topic or from the end of the topic. So this gives us our tools with which we can now pull into a Telegram bot all of these different bits of data that we want. So let's go and have a look at what that looks like. And let's set it running, and then we can have a look at the code as well. So go run. So this is going to spin up the Telegram bot, and it's going to say, right, I'm now listening on this particular place here. So I've launched my Telegram bot, and I'm going to click on start, which will initiate it. And you'll see by clicking on start, that actually sent a command through, which got logged by the bot on the code here. And we can see here, we get a little prompt telling us what we can do. So this is where we can use alert to receive alert when a certain number of places are available. We can give it a name of a car park, and it's going to tell us how many spaces. Or we can even send it our location, and it'll tell us which car park is closest to us that's got more than 10 spaces available to it. So let's set an alert to start with. I would like to know when a car park becomes available, or a car park on the REST API says I have more than a certain number of spaces available. So tell me when a car park has got more than 100 spaces, or let's say 500 spaces available. So we've set that up, and it's created that alert. You'll see here in the code, it's on the log file, it says, okay, we've received that alert. In the background, that's now set running a query saying select from the car park events, blah, 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 where empty spaces is greater than 500, because 500 was the value that we gave it. So now anytime a new message is received on that topic, like now, it will do a push alert out to the user saying, okay, we've received an update and these particular car parks have got more than that number of spaces available. Let's try another one. Let's say, okay, there's a car park called Westgate. I would like to know how many spaces it's got available. So we send it that, and now it's doing a key value lookup. It's doing a pull query against ksqlDB. It says, okay, it's got this many spaces. Also, it'd be kind of interesting to know, well, nearest to where I am, how many spaces available are there? So let's zoom in on the map and give it a particular location, and pretend we're about here in Bradford or in Holmfirth, and we send it that. It says, okay, I'm going to go and do a lookup against ksqlDB, and I'm going to find out which car park is closest. You've got all the kind of some debug information here, and it says, okay, the nearest one is this particular car park. So you can see actually in the debug information in the background here, we can see this many spaces are free, and it's done this calculation, which one is closest to the user. So it's just got a geodistance function as part of it. So that's putting it all together. We've got the Go code is doing the lookup, the lookups out to ksqlDB. So we can go and have a quick look at that. The first part of it simply takes the updates as they come through. And we've got this one here, it says if it was a command, look at what kind of command it was. If it was an alert one, then we're going to pull the threshold out of the arguments. So we say /alert 500, takes that 500, and it passes through as an argument. So we've got a function here called alert spaces. And what that's going to do, if we go to the definition for that, we can see over here, it's now going to go and run this command against ksqlDB, saying select from car park events where empty places is greater than that threshold, emit changes. So that comes through, we do the request against ksqlDB, and we wait for the data to come back. As it comes back, we put it into these Go variables, and we return that back out to a channel. That channel comes back and it sends it out to the user. As we can see here, it's just popped up in the top right hand side. The next part of it says if we get a location come through, then we take that location and we run this get closest, which takes the latitude, longitude. It does a lookup against ksqlDB. This actually does a select against that event stream from the beginning. And then it says, well, take the latest one and just cut it off. It's not actually a key value lookup as such. And then the last one itself is doing a check spaces. So it says, well, we've sent the name. We said like Westgate car park. How many spaces does this one have available? And this one, we do a pull query against ksqlDB. So we say, go to the definition. And here it's saying select the number of empty places from the car park where it matches this name. It does a REST call against ksqlDB. And it passes the message that comes back into these particular values and passes it back as a return from that function, which then sends it back out using the bot API. So that's the Telegram bot using Go client to be able to pull messages from ksqlDB using both push and pull queries to subscribe to changes or do key value lookups. The last bit I want to show you is another validation of why we want to use Kafka as the platform for this, because you can use the same messages that we're using to build out state and do push notifications to also stream the data that we've enriched and processed and push that out somewhere else for analytics. So from ksqlDB, you can interact with something called Kafka Connect, which is a great way for integrating different systems with Kafka, both inbound and outbound. So now we're going to push data from that topic of car park information, and we're going to push it down to Elasticsearch. So to do that, we're going to say create a sync connector, take data from this particular topic here. It's in protobuf because we serialized it as that, and go and push it over to this Elasticsearch endpoint here. So we go and create that. We say show connectors and make sure it's working. And it says, yep, we're running. And now we can go over to Kibana. And in Kibana, we can now analyze the data that we've got within Elasticsearch. So we'll create ourselves a index pattern like this. And the timestamp field we're going to use is TS. And if we have a quick look at the types of data that we've got within this, you can see we've got the capacity, we've got the name, and we've got longitude, latitude. And if we change this like this, we can see down here we've got a location field, which is a geopoint, which is one of the reasons I took that longitude and latitude and made it into a struct, because it means when you push it to Elasticsearch, it kind of just works. So we've got the geopoint, which means we can do some cool stuff with it. We've also got the empty places as a number, and then we've got the name of the car park here, so we can do some analysis on it now. So let's do that. Let's head over to here, and we've got the visualize option and create a visualization. We're going to use lens, which is kind of cool because we can say let's take the empty places, and I'd like to break it down by timestamp going across here, and I'd like to use the name and break it down by that. So you can say show me all of the different car parks, or show me 10 of the car parks, and instead of the last 15 minutes, show it for the last hour. And you can see obviously in the last half an hour or so, there's not been a great variation in the number of places available, but you can see you can start to plot this information out, and it makes it nice and easily accessible. You can collect the data over a great amount of time and see how it varies and do lots of nice things like that. So we can easily plot it in Kibana. We could use that as a dashboard, a real-time dashboard on top of the data from an external REST API, or indeed from anywhere else, because you can integrate numerous different systems and databases and message queues with Kafka and then push that data straight down to somewhere like Elasticsearch to use it for analysis. We can also say, well, let's take that data, and because it's got a geolocation within it, we can actually start to plot that on a map. So you can say, well, here's the maps part of Elastic, of Kibana. I'm going to add a layer over here and do it as a heat map based on the car park events. And we've got the location field is our geospatial bit. And then the metric we're going to use, let's do it based on the empty places. And we can do that and that and save and close it. And now if we fit it to data, we're going to zoom all the way in, and we can see here's Bradford in the north of England where the car parks actually are. And as that finally catches up, it can see, well, it plots where those car parks are, and it's doing a sum of the empty spaces. So it's not saying in this particular location there are this many, but within this timestamp here, so within the last 15 minutes, there are this many different spaces available. So you can see, okay, I'm going to go to this part of the city or this part of the city and zoom in on it like that. So there are different ways you can use the same data. All of this coming from CSV data on a REST endpoint, streaming it into Kafka, using ksqlDB to enrich it, to process it, to reserialize it, doing materialized views on that data, doing state value, key value lookups, using an external client, REST API. We can do event-driven notifications, again using that external client, use Telegram as the platform for that. We can also push the same data down into Elasticsearch and build an analysis on top of it like that. Okay, so hopefully you found that interesting. There's a few little links that I'd like to share with you. If you want to go and try all of this out, you can do so on Confluent Cloud. Confluent Cloud gives you Apache Kafka, it gives you ksqlDB, it gives you Kafka Connect. There's a bunch of different money off you can get from your bill when you go and sign up. There's a discount code there you can use also. So this lets you just spin up Apache Kafka and go and try it out. Makes it nice and easy to start with. When you want to learn more about Kafka, so you've got Confluent Cloud, but what do I do with it now? You head over to developer.confluent.io. There's a bunch of tutorials and podcasts and videos to help you on your learning journey with Kafka, with Confluent Platform. And finally, come along to the Confluent Community Slack group. You can join the different channels there and hang out with the community, help other people, get help from other people in all sorts of aspects around Kafka and Confluent Platform. So hopefully that's been interesting to you. My name's Robin Moffatt. You can find me on Twitter @rmoff. Send me a tweet if you liked it, send me a tweet if you didn't, but be constructive, be friendly. It's always nice to hear from people. So with that, thank you very much for your time and have a good day.